Hey, everybody. Happy New Year. Yay. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about, what you're doing this year, this channel, whatever it is. Just, hope you're having a good time. Hope you accomplish all your goals. People in my Discord has been kind of talking about, all the victories they had and just things that they're doing. You may be wondering why at this point I am not wearing a shirt. Well, it is because I'm in Panama and it's really hot, but also, to kind of go with the mood in the intro. Hopefully, it's a thing I'm doing because it's New Year's, and maybe I'll be doing it for special events and hard problems. We'll see how that goes. Yeah, I don't know. Let me know if if this is too much or you have fun with this. I don't know. It doesn't really matter that much. Okay. Today's problem is burst balloons. A hard problem. A good way to start of the year. Just to also give a note, I have a 640-day streak or something like that. Actually, I don't really know. Should double check that. But what I mean is that I've done a video for every daily video things for the last year and 8 months or whatever the math is. I don't know. I can't do calculations. But yeah. So if you're new to this channel, you're watching on New Year's because that's your New Year's resolution, or you just want to stop by, feel free to subscribe, but just come back every day. Come check solutions. I don't always have the best, but and just check it out. All right. So all the ad stuff aside, today's problem is burst balloon, a classic problem that is, and I don't mean to say classic as in it's going to be easy, because I actually struggle with this one a lot. And you probably could find videos on me doing it previously, including the first time I did it, which not the first time, but the first time I've done it in like a decade, but a couple of years ago at this point. I think one thing that I would say about okay, let's start by saying this is a dynamic programming problem. If you struggle with this dynamic programming problem, I would not look at this one first. There are definitely a lot of things you can work on getting to this point, because even though I was probably, I wouldn't say like really, really good, because people also have gotten better over time, but at a certain point I consider myself pretty good at dynamic programming, and even I struggled because there were certain mind blocks, say, that I struggled with just from, I don't know, just from our practice, or maybe my understanding of certain aspects of dynamic programming, including the states and something like that, was incomplete, or maybe I just didn't learn it as well as I thought. But hopefully this time I did. The key thing about this one that I see myself struggling with, at least a little bit more in the past. I still kind of struggle, but a little bit less, because these are things that, of course, with more exposure will become easier, but it doesn't come up as often in the stuff that I'm doing now. Leetcode, it doesn't get that difficult generally with dynamic programming, and I honestly haven't done like more harder competitive programming in a while. That said, so the hard part about this the aspect is that it is not symmetric. So I do bring this kind of concept up from time to time with dynamic programming, and the reason is because in a lot of things, it is symmetric in the sense that you can go from left to right or right to left, and it gives you the same answer. You just have to, like maybe it's plus instead of minus or something like that, right? You go both directions. Or if you go like, down, like one of the Pascal triangle E things where you go from top left to bottom right. Well, you could go from top down to bottom right, or go back up in a similar way, and you get the right answer for like, let's say shortest path going in that right direction or whatever, right? So there are a lot of things that are symmetric, and at least for beginners, or not even beginners, but just like a lot of these problems by construction is symmetric. So what that means is that it lets you get away with being slightly wrong, unless you really understand it. You might not, be, like proof by AC is, maybe good enough for certain cases, but it's still, like there is an underlying understanding that is a little bit lacking. And I'm not, trying to be judgmental, because a lot of this, I think I'm speaking to myself, to be honest, and trying to self-reflect on my challenges and kind of understanding these sort of problems. So the key thing is that it's not symmetric, so it really matters which way you go. So that's the only thing that I would say before we kind of dig deeper. We're already 5 minutes in, so hopefully you're still here. If so, leave a comment in below about your favorite balloon animal shape, so I know who's actually watching here, instead of skipping ahead or skipping whatever. And people should be skipping ahead if they don't find it useful. Watch it on 2x, whatever you need to do. But I'm just also curious who actually listens to all these stuff. But okay. So yeah, my favorite balloon animal is probably a unicorn. It's just cute. It's just like a horse balloon with a horn, right? So I guess that's okay. Now, that said, let's burst this balloon. So the key thing to know about this problem is that, like I said, it's symmetric, and then it is what I would call that divide and conquer dynamic programming. And there is a concept behind dynamic programming called this idea of you have these subproblems, right? You have a problem, and then you have these subproblems, and you have these like you have these concepts of the subproblems leading to the concept of optimality, where these subproblems build up to the best solution. In addition to that, I mean, that's a lot of mathematical stuff, but in addition to that, I want to say that the way that I think about it and the way that I try to think about it, and for me, in a way, it almost is easier than, say, a greedy algorithm, in that it is just brute force with a couple of concepts and kind of collapsing states or whatever. But an idea, the mathematical concept that I think about it is brute force, and trying to think about a quote unquote smart way or clever way to brute force. Because once you're able to brute force, then you can prove that it is, if this is brute force, then you're able to prove it much easier, right? Of course, there's technically speaking greedy aspects that built on top of this. And what I mean by that is that, in this case, you want to return max score or max coins or whatever. And of course, the max is going to be a max in this case, like the function is kind of linear, right? So in that way, these components, you could separate them to the components and then max them together. And in that way, of course, that's where the greedy aspects come from, right? You just take the greedy subcomponents, subproblems that gives you the best answer, and then combine them in a way, and then see if that gives you a best local answer. So that's kind of the ideas that we're dealing with. These are all the concepts that I'm talking about. Hopefully that makes sense. I know that sometimes I tend to go a little fast, but you're watching a video. Feel free to rewind, or this is the internet. Feel free to join Discord and give me a chat or in the comments or whatever, right? But hopefully these things are things that kind of, obviously it's not the answer, or like not only the answer, but hopefully these concepts will help you unlock understanding burst balloons, instead of just like, okay, look, because I do see this from time to time from people, and I'm not a fan of this, where they're like, oh, let's see the code. And then the code is like, okay, how do I change this code to work for burst balloons? How do I change this burst balloon code to look like another problem code that is similar, right? And, that's not the way to really understand it. If you really do understand it, you only have to learn it once. That's the grand idea that I'm presenting. Okay, so the key thing here is, and I said this a couple of times, is that it's asymmetric. And what I mean is, instead of thinking, okay, first I want to burst this balloon, and then what happens, right? Once you burst this balloon, you have these subcomponents that you have to kind of, merge and so forth. And then another way to think about it, of course, is what we already kind of hint at a lot of times, which is doing it in reverse, where it is not symmetric, right? Where you, instead of looking at the first balloon that you burst, think about what happens if I burst this as the last balloon. Well, if I burst this as the last balloon, that means where my borders are from the left and to the right. So let's say we have, okay, these are kind of terribly simple examples. So let me expand on this a little bit. I'm just banging on the keyboard like a cat on that meme. But the idea is that, okay, let's say you have a subsequence that's like, okay, let's just look at this subsequence, right? Where we want to get the subproblem or sub-solution for this subproblem, right? And then here we have the left and the right. And then the idea is that, okay, let's say we only care about this component, and let's say we burst this 5 last. What does that mean? Well, we burst this 5 last means that we already burst this problem and this problem, meaning that we have a score for this after we burst them in some order. Like, we don't know the order per se, but let's say we burst these 2 in some order, and then we get a score from bursting 6 in some order. Well, there's only one number, so I guess 6. Let's say we burst that one, and then after we burst everything here and everything here, then that means that we are now at here, which is what we kind of look at when we want to burst the middle 5 last. And here, then it's easy to calculate the score, right? It's just the score of these components, and then bursting the 5 will give you a score that is according to this formula. And that's basically the idea. And if we're able to brute force it, then we should be okay. I hope this is okay though, because one reason why I just said that is that the idea behind this algorithm is going to be n cube. It is n choose 3-ish, so it is actually a bit faster than that, but we'll see if this is fast enough. Yeah, let's see. Because usually they do have a lower constraint for n cube ones, and I'm not aware that there are any quicker ones. Though if there is, let me know in the comments, or maybe we'll cheat. But yeah, so basically that's the concept, and let's start writing. Calculate max for range, say, I don't know. Right, and you have a left index and a right index. This is a hard problem, and I know that this is the first day of the year, but I would also say that if you, sometimes I do explain it, but this one I want to focus on the harder components. And here, let's just say that you can put in the subarray that into the function, but of course you'll notice that that is uniquely determined by the left index and the right index, and that's why we're able to do this. And of course, just to kind of write whatever, the score for bursting left, right, inclusive. So that this is the contract that we tell ourselves, just in case you get a little bit weird, because, or if you get off by 1 to whatever, this is the thing that I, at least myself, come back to. And what I mean by that is that sometimes you forget whether you do inclusive or exclusion or exclusive or whatever on the bounds, and it's very easy to mess up, to be honest, because whether it is inclusive. Sorry, friends. I'm in Panama right now, and this is actually a couple of hours before New Year's here, even though I said Happy New Year, so I lied. But a happy thing that people do is a lot of fireworks. I'm a little bit distracted by fireworks, at least the sound. I don't know if you could hear that. If you can't hear that, that's fine too, but apologies for that. But it is a key thing to keep in mind, the inclusivity. I mean, you don't have to define it as inclusive, but that's the way that I do it, because otherwise, it's just easy to do off by 1, and you have some function here later on. What the? I just banged on the keyboard and that came out with curse. How did that even happen? But yeah, you have some function here that deals with the left and the range, right and the range. But then sometimes you just like forget whether you're inclusion or exclusion, and you have off by 1. So that's why I try to be careful. Okay. So let's say if left is equal to right, then we have only one balloon left. So then here, Is it possible to have only one balloon left? I guess not. Okay, let's actually change this a little bit. What is our base case? Our base case, I guess, will have 3 balloons. Let me think about this for a second. I actually don't remember what I should do for the base case. I am solving this live, so yeah. Okay. Let's just write this for now, and if I'm wrong, then I'm wrong. And then we could adjust, but yeah. And one thing I do want to do is actually, treat it as if it has ones on the ranges. So without having to care about, handling these edge cases or whatever, let's just, let's just change that. And of course, we'll have to remember to return calculate max for range of 0 and n minus 1, where n is you go to new nums. And of course, now this is where our contract comes into place. We actually want this to be exclusive, so we don't actually burst the left and the right. So I lied here, and because of that, that means that if this is true, then we return left plus 1. Technically, it's this plus or this multiplied by left and right, but in theory, I don't know how I feel about this actually. Okay, let me think about how I want to do this when we kind of write it out, right? Okay. So yeah, so this would get determined by what we do here as well. Maybe okay. I don't know. This one is a hard problem. I don't know, but I mean, it's actually fine as long as you're self-consistent, meaning that as long as you're consistent everywhere, it should be fine. But yeah, let's kind of get to it, and we'll maybe play around the thing first. But then yeah, now we want to burst a balloon, right? Let's say we want to burst the number x, so we build it from range from left to right, inclusive. So that's why I write it like this. And then now, what is this, right? So best, let's say we get score of 0. There's no negative in here, right? No, okay. So yeah, then what's the score for getting this, right? It is max of best of calculate max for range from left to x, right? Plus calculate max for range from, is this x? I guess this is x minus 1, right? Because this is inclusive, you're not going to burst it again. But that also means that this should be left plus 1, and this should be inclusive going in the middle, because otherwise that doesn't really make sense. And then burst it on the right. And this is inclusion, so this should be fine. And then plus the score for popping this current balloon, which is num sub x times num sub x minus 1 times num sub x plus 1. Of course, this cannot go around just by the constraints that we're met with. And then at the end, I think that's pretty much it. I'm a little bit shaky about this one, to be honest, or I don't feel so good, just because of the possibility of off by ones and stuff like that. But conceptually, the idea, I think it's okay. I think this only goes to 100, so that was a wrong thing. So let's give it a go. Of course, I haven't done the memoization yet, so we'll look into that in a second, but let's just see. Okay, so we're doing very well. Okay, so if this is inclusive, then we have to burst these as well. Okay, so let's actually, I was thinking about how to do this, but yeah, if left is greater than right, return 0. So basically that means that there's no balloon to burst. I guess that's better than putting the if statement here, maybe. I don't know how I feel about that. Okay, so we fixed this case, which is good, but then we didn't fix the other ones. Wow, I am very sloppy today, I guess. Why is this returning 98? am I lying? Did I actually burst some balloons? I might be not bursting some cases. All right, let's try. The bounce on this one is kind of tricky, or the base case, because I think this is relatively right, to be honest. But this is where I'm getting wrong. Okay, 13. So that's weird because you don't expect to get bigger than whatever. So that's bursting left. I mean, this seems right. Oh, I messed up here. So that's why I said it's so easy to mess up, and I talk about it for about 10 minutes about what to do in this problem, about asymmetry and symmetry, but I still mess it up, right? But of course here, we're not choosing the next balloon to burst, we're bursting the last balloon. And when you burst the last balloon, that means that all the balloons within the range is burst, and that means that the last number is actually left and right? But now everything feels a little off, to be honest. So I think these may be a little bit off. But yeah, okay. I mean, we're wrong, but at least we're happy about it. Because I think now a lot of these base cases are a little bit awkward because I confused myself with bursting it last versus first. And first it doesn't really quite work like this. But bursting it left and right, so we have these 3 balloons left. Here, that means that we're going from 0 to n-1 now. Yeah, because okay. And then now, okay, I have to recalibrate my mind. Sorry, we talked a lot about this and I still get it wrong. So yeah, tells you how hard this problem is, and I've done it before. So yeah, okay, let's think about this again. So okay, if we want to burst these balloons, this is okay. Maybe this is still 0 because now this is really awkward. Let me think about this. Well, in this case, this is exclusive now, right? So that means that if left is equal to right, this is 0. And if this is exclusive, then we want to do something like this anyway. I think this is a little bit better, but now we're just doing random stuff, it seems like. But I think maybe I'm just off by something here. Let's see. Let me just fill out for the logic, right? Okay, so we have the left, and then this should be left plus 1, and this should be right minus 1, right? Because now we have this left and the right, and we're talking about the stuff in the middle between these things. Oh no, but it's exclusive. So since this is exclusive, it should be this now, because now we don't care about the bounds. See, this is where having this reminder helps, because then now I could look at my bounds and be like, oh no, this is exclusive. See, so I don't have to like rethink about my strategy a little bit. I just have to look at my things, and look, it worked out, right? This is why I point out that it's very important to really knock down if you struggle with off by ones and stuff like that anyway, whether you want inclusive and exclusive and then everything follows through. Sometimes some problems is easier with inclusive and some problems are easier with exclusive. That's why sometimes I jump, or you see here, I jump between the two in that what is easier to represent, because then it's not that much harder. You just have to be consistent, like I said, but there'll be more if statements and so forth, right? Okay, so of course, if you're up to here, you know that we need to cache this basically, right? Because this is exponential. For each pair of numbers, we do a ridiculous amount of work. So we definitely need to clean this up. Let me also just add one more test case. But yeah, we definitely need to clean this up. And of course, if we just show any big enough number of these, it's very easy to demonstrate, right? Like even this is not even that many numbers, but it should time out regardless. And n is 500, so if this doesn't time out miraculously, it'll time out easily if we just double it. But yeah, so the idea here is that, okay, for dynamic programming or memoization, for every input left, right, I guess technically they're not inclusive, so you could write this like this. We get the same answer. And because of this, we do something called memoization, which means that if we see the same inputs again, if we already know the answer, we just return it. That's basically all memoization is. Dynamic programming is a funky sounding, complicated term, but that's basically all it is, right? There's nothing really that complicated about this per se. So let's do that. Let's put cache is equal to let's has cache is equal to force times oh, what am I doing? Right? And this is whether to see whether we have cache, and then we just, the actual cache, though of course it doesn't really matter because this doesn't really matter because we're never going to use it unless it has cache. So now we can do something like if has cache of left, right, return cache of left, right. Otherwise, cache of left, right is you go to best has cache left, right is equal to true. And that's pretty much it. Let's run it again, obviously. And yeah, you can see that it happens much quicker. Let's see if we could. I want to see the 500 case at least once. So that's 10, 20, 30, 40, 50, 100. Is that 100 once, really? 2, 3, 4, 5, and there you go. Well, well, that's awkward. Did I miss something? Just doing some micro optimizations, but that is a little discerning. That was 500, right? I didn't do like anything really funky or anything. Not sure what the deal is here, to be honest. 14 seconds is not really acceptable, but and this actually went with my. I don't know when it gets some. I guess 500 is about right, but let's see. Oh, whoops. 14 seconds, really? 11 seconds. 502, yeah, okay. I don't know what to say. But in any case, the explanation is right, even if Leetcode's being a little funky today. Maybe a lot of people are doing it. I don't know. It's a little bit awkward. Let's see. Let me try something real quick. So you can do this bottoms up, but I don't know if that helps enough. That's my problem. So that's why I'm gonna. Let's see. Sorry, hang on. So I'm just I'll do an explanation, I guess. But so this is much faster. I mean, so one thing that is annoying about Leetcode is that they don't really care about Python as much, clearly. And one thing is that functions in Python are kind of expensive, which is why you saw me kind of got rid of the max. But there are stuff that is harder to get rid of. So basically, what we're doing now is just converting it to bottoms up. It's not that hard, but it just takes a bit of practice. It has the same logic. You just kind of have to look at this function and then convert this function that we have into a for loop. The only hard part about this is kind of writing the for loops in the correct order, to be honest, because where here, you don't have to care about the order in which you do the calculation. In dynamic programming, you do. In this problem, it actually might not be as tricky, but it might be that in other problems you might have to look out. So let's kind of do that. So the idea here is that we have to convert the base cases, which is if left is greater than 0, but we start right from the left. So even in that case, that's not possible. But if left is equal to 0, then cache is equal to 0 anyway. So maybe or if left is equal to right is equal to 0, so we can start with left plus 1. And then for x, we go from left to right, which is just the same as this loop. So that should be pretty okay. Yeah. And then now we write the same thing here, but instead of calling it cache, I call it DP just for my, it's just something that I've always done. So excuse me, but here you can see that, this is just, you go to this thing. Right. So here we can set, you go to best is equal to 0. We said this is, but of course we already did this here. That's why I didn't, but I just want to write this out so that it is, more explicit for the viewers at home. And then now we're just converting this for loop, which means that, you have this thing, let's just say score is equal to, or coins maybe, is equal to this thing, which is of course dp of left of x plus dp of x of y plus num sub x times num sub left times num sub right. And then if score is greater than dp of left and right, then I always write it. I make that mistake a lot. Not this time though, at least almost not. So that's pretty much the idea. Let's wanted to see if that's right first of all, and see if that's fast enough second of all. Okay, wrong answer, but I have a typo. Am I doing it in the wrong order? As I said, no, I think this is roughly right, but why am I getting the? Okay, at least I got the last answer right, but the other is not so much. Let's see, am I doing it in the wrong order? Yeah, I am doing it in the wrong order, am I? Because basically I'm doing it in the wrong order. Okay. So then now, that's annoying to convert then. So the reason why we're doing it in the wrong order is because, I mean, you could just kind of trace it, and if we trace it, we calculate this while this is 0 before this gets calculated. I think this part is fine, but this part is the wrong part. So yeah, okay. This is kind of an annoying one to convert, but conceptually we have to the functions right. How do I rewrite this in a good way? But basically, you want to calculate all the segments of size 1 and then 2 and then 3 and then 4. So that basically is the idea, because if you think about it, you're building it off from smaller components to bigger components. So in that way, you are able to kind of do it that way. This one, they made it annoying, but okay. So then let's keep this here for now, but now let's change the definition, right? But basically, instead of, so before we said that dp is equal to, or dp of left right is equal to something exclusive bounds or whatever, right? But now we want to do something like dp left and then size maybe is basically same thing, but in a way that's easier to iterate. I guess I don't need to do it this way, but let me think about this. I think I could write it that way as well, but I could still do it in this idea. We just have to write for. Okay, so then now we go for L in range sub n, maybe n minus 1, but okay, from left, and then here we can do dp of left of left plus L. Let's also start. Let's start this at 1, right? Because then we want this to be a left plus 1. Does that make sense? No, because I think in our other function, which we deleted because I'm silly, technically if left plus 1 is equal to right, the inner for loop never executes, so it just returns 0. But so it was an implicit base case, even though I was not correct here. But here we can actually skip it by making it 2 as a result. Okay. So we set this equal to 0 again. I know that is here a bit, but yeah. But of course, we also, let's check that f plus f is less than n, which we can of course just write this here then. Right? Yeah. Yeah. Okay. And then now we go for x in range of, and then now we could set maybe right is equal to left plus L is a little bit clearer. And then now we can do the same thing as we did before. We just now have it in a different order. Okay. So it's not always straightforward converting this. This is a little bit trickier than usual. Hopefully this is right. I don't know if this is right. My DP might not be right, or like the bounds on what we accept. But that seems okay for this one. It's still so slow, 5 seconds. I mean, it is twice as fast, but it is also much slower. We probably could do a little bit better with this array, because most of this array, well, maybe not most, but half of it is 0. So your but it's only 500 squares, so maybe it's not that bad. Yeah, okay. I don't know if this is good enough. Let's give it a submit. 5 seconds is still really slow. Apparently my older solutions is good enough. Maybe we'll have to convert it to another language if this is a little bit yucky. But I guess they changed the test cases then, right? What did I do last time? I did it with dynamic programming last time. So okay. So if you want to see the memoization top-down version, this is the explanation, or like we had the explanation, so you can see that it used to work. It might still, I don't know, because even my test case is 5 seconds, 6 seconds, and when I ran the top down, it was 11 seconds or something like that, right? So it probably would have timed out. I guess they just add a lot of test cases, or maybe I don't know if the bounds were higher or something like that. But it's a little bit awkward because I don't know. And of course, I did in C++ way back when. And I did this in this really funky way because I wasn't sure about my bounds and stuff like that, which is a lot of the stuff that we talked about. Anyway, I actually didn't see my streak because someone pointed out that I should bring it up. So maybe tomorrow. But yeah, this was a very long video. longer than I expected for a problem that I know how to solve. But hopefully the exploration and kind of the things that we talked about, it makes sense. And even though it wasn't structured as a specific specific even though this is not structured as a specific tutorial, I hope this was a really good in-depth video of just this genre of divide and conquer, and then also converting it to bottoms up, even though maybe I hand waved a little bit toward the end. But the idea is that you have to do things in the right order, and yeah, and basically after you convert, make sure that this is in the right order by having length this way and defining it this way. Everything else is the same, right? We didn't really change anything else except for the loop order, and kind of made it a little bit different. So yeah, let me know what you think. This is a really weird one. Happy New Year again, everybody. Hope y'all have a great year. Hope you had a good last year as well. Mine was tough at times, but whose isn't, right? Anyway, stay good, stay healthy, to good mental health. I'll see you later. And I'm going to show you one more drone footage before I go. See ya, bye-bye. And I have to press the button for you to see it.